Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also I am going to discuss about a material property that is very much important in the civil engineering. That is yield strength and the ultimate strength. Mainly you are using it in the steel river. What is yield strength, what is ultimate strength, what is the difference in between, and why these two are important. In today's video I will discuss each and everything about the yield strength and the ultimate strength of the material. So stay tuned until the end to get the full information about the yield strength and the ultimate strength. So let's jump into the subject, and if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. So without wasting time, let's start. That is, what is yield strength and what is ultimate strength. So what is the definition? The definition of yield strength is the stress level at which a material begins to deform plastically. Up to this point, the material deforms elastically and will return to its original shape once the stress is removed. Now, the terms is coming stress. Now we need to know what is stress. Stress is defined as the internal force per unit area that resists deformation in a material when subject to an external force. Now, why it is important? In any structure we are preparing or we are making, that there is an external force. Now, whenever this external force is applied on the material, that is on the structure, that's beam, column, and whatever it is, now it has a tendency to deform. Now the stress is the defined is the internal force per unit area that resists the deformation in a material when subject to an external force. Stress tells us the internal resistance of material experiences when under load. Now, this is the stress. Now, what is the formula of stress? That is the force per unit area. It is measured in Pascal or Newton per millimeter square. So, what is that? There is a tensile stress, compressive stress, shear stress, exactly. Now, for the stress also, we need to know another term, that is strain. Now, what is strain? Strain is the measure of deformation representing the displacement between particles in the material body relative to a reference length. It describes how much a material stretches or compresses in response to an applied force. Strain tells us how much the material deforms or stretches as a result of the load. Now, whenever load is applied, either it is a compressive load stress or the tensile, depending upon the load, either it can compress or it can elongate. So what is the percentage of elongation is there under load? That is become the strain. So strain, what is the formula? Change in length or divided by the original length. It is always a ratio. So represent a ratio, that is a length. So this is the strain. So any structure that is undergo a subject to a external force or external load. Now, whenever this external load is applied, stress and strain, these two terms is very much important to understand the yield strength and the ultimate strain. So we have already discussed what is strain and what is strength. Now let's take an example to understand which one is the ultimate strength and which one is the yield strength. Let's take an example. When we are applying load or applying force to the reinforcement bar, it start to elongate, or the strain or stress is generating. So what is happening? First, it is check in this graph. This graph is stress and strain. In the x-axis is strain and the y-axis is stress. So whenever we are applying the force, due to the strain, stress is generating. Now what is happening? From O, it is coming parallel to point up to A. So what is the portion O to A? This portion is absolutely straight, where the stress is proportional to strain and the material obeys Hooke's law. The value of stress at a point A is called the proportional limit. So here it is, from O to A, the stress is proportional to the strain and the material obeys the Hooke's law. So whatever the strain is generating, that is proportional. So we have no problem. Now, what is portion A to B? In this portion, Hooke's law is not obeyed, although the material may still be elastic. The point B indicates the elastic limit. Now, what is elasticity or the elastic limit? That means whenever the force is applying, it is strain is increasing and the stress is generating. Now, when the force is not there or remove the force, the material is coming to its own position or own length, so it can return. Suppose you have a rubber and you stretch it out, and when you are remove this rubber, again it's become shrink and it become as per the actual length. So these are the elastic limits. So portion A to B is the elastic limit. Now again we are increasing further load. So whenever we are increasing further load, what is happening? It's coming portion B to C. In this portion, the material shows a strain even without increase in stress, and strain is not fully returned when load is removed. So in this case, in B to C, two things is happening. The metal shows a strain even without increase in stress. So stress will not increase, but strain will increase, and it will not fully return when load is removed. So from this point, from B to C, it is a tendency that the material will not fully return when the load is not there, and also it shows strain even without the increase in stress. Now, if we again increase the load on the structure or in the material, what is happen? Then the curve will come from C to D. This C to D is yielding start in this portion, and there is a drop of stress at the point D. See, strain is increasing, but stress is decreasing. Before, the strain is also increasing and the stress is also increasing, but after point C, the stress is decreasing but strain is increasing. So what is point C to D is representing? Yielding start in this portion, and there is a drop of stress at that point D directly after yielding begins at C. The point D is called the lower yield point and C is called the yield point. So what is the yield point? That is the yield point where the material loses its elasticity and it will not return to its initial stage when the load is removed. So this point C is called the upper yield point and D is called the lower yield point. We are always calculating this upper yield point when we are designing in the elastic limit. Now, what is happening if we increase load further? Then this graph or the material shows from D to E in like this curve. So what is this portion D to E? This after yielding has taken place at D, further straining takes place at this portion by increasing the stress, and the stress strain curve continues to rise up to the point E. Okay, this strain in this portion is about 100 times of the portion O2A. So from this point to this point is 100 times, and the point E is termed as the ultimate stress point or ultimate tensile stress point. Here, what is an after point D? Whenever increasing the load, this is showing like this, and after E, when we increase again the load, what is happen? It will come out as like E to F. Also, what is E to F? In this portion, the load is falling off from the maximum and fracture, and F takes place. So the F is termed as a fracture or breaking point, and the identical stress is called the breaking stress. Now, if we increase load from point E again, then the fracture will happen, and this point is called F, the fracture breaking stress or the fracture stress. And this point of E called the, what is the stress is there, is called the ultimate tensile stress, because after that, if we increase the load, it will break or fracture will happen, and after that there will be no existence of the material will not take any further load, so their structural stability will be a problem, so we will not get the structural stability. So what is this point C is yield point. Here up to this is the elastic limit. That means when we remove the load, the material will come to its own position, and after that we increase at a point of E, it will start breaking the load, and the F, it is the breaking load or the fracture load, and this point is called the maximum or the ultimate strength. So in the graph we can see the E, this is the ultimate tensile strength is more than the yield strength. So we are designing on the basis of the yield point or in this point, because after this point the fracture will happen and it will not return to its in own position. So from this test and curve we can understand what is yield stress and what is ultimate strength. Now what is the difference in between ultimate strength and the yield strength? So definition: yield strength is at which material deform plastically, but in the ultimate strength, maximum stress material can withstand before fracture. So it is the maximum point. So what is the nature? In yield strength, it represents the start of plastic deformation. So the yield strength, after yield point it start the plastic deformation. So again that we already discussed that the material will not return if the load is removed. But the ultimate strength represents the point of maximum stress before failure. After that it will fail. And the behavior: yield strength elastic behavior transitions to plastic, but plastic deformation leads to fracture. So it is very much important that in yield strength is the elastic behavior transition to plastic, so from elastic to plastic. But in the ultimate strength it is the plastic deformation to the fracture. So these are the behavior problem and the difference. And what is stress levels? It always yield strength, from the graph we already understand it's lower than the tensile strength, ultimate tensile strength. Now why it is important? Yield strength used for designing safe elastic structure, and ultimate strength used for understanding materials breaking point. So we need to know which is the maximum point when the material will break, but we are designing on the basis of the yield strength. So unit is always MPa or megapascal or the PSI, and the same unit for both. An example in construction, we can take one example that for the steel, if we have the Fe 500 steel bar, that means the yield strength is 500. Fe 500 means the yield strength is 500. It is not the ultimate tensile strength, it is yield strength. The steel breaking, maybe it's 650 or 600 or 670, whatever, it is always greater than the yield strength. So these are all the differences or the comparison table. And if we can take one example, that is say for example Fe 550 grade of steel we are using. When a load applied to a steel bar, it can withstand stress up to 550 megapascal without undergoing permanent deformation. This ensures the structural integrity of concrete elements like beams and columns under normal load condition. So up to this point it is a normal condition, and whatever the stress and strain is generating, when the load is not there, it will again come to the original position. But what is the ultimate strain? Under extreme condition, that is earthquakes, excessive load, the same rebar can handle stress maybe up to 650 MPa before it fractures. Beyond this point the steel will fail, leading to structural collapses. Now, why this point is important? Because safety, the material selection, design optimization, these are the things you need to know very well before selecting the material. So these are all about the difference in between yield strength and the ultimate tensile strength for the material. I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. And thank you once again for watching me.